Hello, and welcome back to Calero Academy. Today, we'll be looking at a differential equation from the textbook Stewart Calculus. The question asks us to solve the homogeneous differential equation dy over dx is equal to x squared plus y squared over xy. That hint that it's a homogeneous equation is a big help, because a homogeneous equation simply says that you can turn that equation into another. You can substitute a variable v is equal to y on x, and from there, the homogeneous equation promises you that you can turn that into a separable differential equation which can be solved with ease. So, looking at this, let's want to solve instead of want to show. Solving, let's see. How can we write this as a v is equal to y on x? How can we substitute v into there? Well, we can rewrite this as x squared on xy plus y squared on xy. And this equals x on y plus y on x, which is going to be equal to, with our substitution, 1 on v plus v. In the homogeneous equations, there's this formula which says, actually we might as well just show it here. So y is equal to vx, therefore y is equal to xv, therefore y, the derivative of y, is equal to v plus xv, the derivative of v, because that's just a product rule. And then we also know that y, the derivative of y, is going to be equal to some function of v, gv. That's what we're going to try to find. And then after we equate these two equations, we are going to get the formula that v, the derivative of v, is equal to g of v minus v over x. Okay. So now what we're going to do is that we're first going to try to solve. We're just going to try to put this in here. We're going to try to solve for x and v. That's not quite clear. So what we're going to do, we're going to write v prime, the derivative of v. V prime is equal to, this is equal to g of v, by the way. This will be equal to 1 on v plus v, that's this guy over here, minus v all on x from this guy, or 1 on vx is equal to the derivative of y, of v. Why do I keep saying that? So, from here, we can now write the derivative of v as dv dx is equal to 1 on vx. Now, it's just going back down to our differential separable equation skills. We multiply both sides by dx, we get that dv is equal to dx times 1 on vx. A little bit messy there, sorry. Multiply both sides by v, we get that v dv is equal to 1 on x times dx. Take the integral of both sides, and we get that the integral of v with respect to v is equal to the integral of 1 on x with respect to x. Now, this is just going to be equal to v squared on 2 plus some constant c, we can subtract that from both sides. It's going to be equal to the natural logarithm of x plus c. We always have to remember to put in our constants when we're not doing definite integrals. So, now what we do, we just try to get v by itself. We have v is going to be equal to 2 in the logarithm of x plus some new constant c. V is going to be equal to the square root of that, just from some little manipulation of this. Plus or minus, So, now we can write from this over here, y is equal to xv. So, therefore, y equal to xv is equal to plus or minus x times the root of 2 times logarithm of x plus c. Now this is about done, but we can just, for niceties, we can write a neater formula. Plus or minus x times the root of in the logarithm of x squared plus c from logarithm arithmetic. And that has been it for the Calero Academy lesson. Thank you for watching. As usual, if you have any questions, you can write them down in the comments area below. And if you want us to do a video of something, you can put it down in the comments, and we'll see if we can make it. Thank you.